Hi and welcome to 2017 Paper 2 Junior Cert Higher Level. We're looking at question 3 here, and I suggest pausing it and just having a go at the parts A and B on the screen. If you want this set of notes with the screen grab questions and the answers on the second page, just send me an email at shanetroy@gmail.com, and that email address is in the description below. So question 3 here, part A and B are marked together. It's a 15D scale. And normally with these, if you get one part fully correct, you get the 10 marks. Okay, so let's hope the first part here, part A, should be fairly doable. Just be careful with these volume questions and area volume questions to read it very carefully. You don't get the wrong formula by accident. So Kerry has some ball bearings. Now ball bearings are circular. Each one is in the shape of a sphere with a radius of 6 millimeters. So the radius is 6 millimeters. Could be very easy there to read that and think they're giving you the diameter, which they sometimes do. So part A then says, find the volume of one ball bearing, give your answer in millimeters cubed in terms of pi. Okay, now I haven't got it open, but I'll be able to find it pretty quickly. This is the copy of the maths, digital copy of the maths tables. So you're looking at, this is area / volume, so we start up there. That's a sphere, okay, and you have your surface area formula there, which is commonly used and is incorrect. This is volume, it says in the question. So I suggest having your maths tables handy during the exam and make sure you look at it and don't just assume you remember the formula, because I see people here often making mistakes and they go maybe 4/3 pi r squared or any number of variations of that, and that's incorrect formula, therefore incorrect answer. If you're using the right formula and you put something in wrong, that's one thing, that'll still get marks, but incorrect formula gets 0. So I have the formula written here on the notes. Okay, I'll go straight to the answer to save instead of doing it out again. I've written down my formula. Now, sometimes it's worth writing out the stuff you have, but in this case it's just the radius, and we're putting it in instead of the term r, and you have a calculation there like we've done the calculator. Okay, your calculator will probably give the answer in terms of pi, which is what you wanted, but in another question they might ask you to give the number in decimal form and round it to a number of decimal places. So be careful you answer what they ask, and make sure you put the units in. Very, very, very important. Over a whole paper, I've seen people lose 15-20 marks by not including units or rounding correctly, and that's a lot of marks in an exam to be lost for something so simple. Now that's part A. So Kerry then is going to melt down some of her ball bearings. She will use this material to make a sphere of radius 25 millimeters. So she's taking all the small balls and making one big ball. So part B here, find the least number of ball bearings Kerry must melt down so that she has enough material to make a sphere of radius 25 millimeters. Okay. Now if you already know the volume of one ball bearing, if you can find the volume of this larger ball bearing or sphere, you can divide the two numbers together. So small and big will tell you the number of times that occurs in the bigger number, which is the number of ball bearings she has to break down. So you know the radius of the big sphere. So again, we'll just find the volume of that. It's the exact same as part A. Put 25 in. I'd suggest leaving it in terms of pi. They don't say you have to, but it'll make division much easier. So then you're looking at basically, if you have a big ball bearing, okay, how many of these smaller ball bearings are there in that big bearing? So that's division. Okay, now it's set up there in the notes. If you do it by hand, the pi's will cancel. Okay, and divided by itself is cancels. But I would suggest you use the calculator, that's what it's for. And you should end up with an answer of 72.3. But you're asked for how many ball bearings. There's no such thing in this scenario as 0.3 of a ball bearing. You'd have to melt down a full ball bearing to get that. Okay, so the number of ball bearings is 73, and that's it. So I'm not missing anything. Okay, so that's part B. Now part C here is what 5 on a D scale. It says here, Kerry has 350 ball bearings in total. Find the radius of the biggest sphere Kerry could make if she melted down all 350 ball bearings. Give your answer correct nearest millimeter. Okay. Now in this case, you're going to know the volume of the 350. Okay, by simply multiplying the 288 pi by 350. That tells you the volume she can make, but you want to find the radius of that big sphere So you put it equal to the formula, the volume formula, and just equate for or solve for R. So let's go through it here. That's the volume of one ball bearing. Now, I've made an error here in the notes. So I fixed that now, so it should read the 350 bearings. I wrote down the mistake, but didn't actually apply that in the calculation. So the calculations are still correct. So it's 288 pi times 350 gives us this big number, 100,800 pi. Now that equal to the volume formula. We know everything else except the R. So now have to do a bit of trick work here in order to solve it out. Now my first algebra step is getting rid of this pi. Now there's something we would focus on in honours leaving cert, but honours junior cert is fairly valid. If something's common both sides on an equation, they can be cancelled. You could argue I should divide both sides by pi to remove it, but ultimately what's going to happen is if there's pi on the left and pi on the right, it's gone. Okay, that's the effect of the algebra. So instead of having to do the step, let's just get rid of it. So you're left now with 4 over 3 times r cubed equals 100,800. Now, question now is what to do first, okay? I would go in reverse bomb das, move the fraction, okay, 4 over 3. Now it's multiplying on the left. When it comes across to the right, it becomes divided, okay? So the end of this calculation here. Now that's calculator work. You could do it by hand, but if you were to do it by hand, you turn the fraction upside down and multiply. But I end up by using the calculator. I got 75,600. Now that's the cube of r equals that number. So if I bring the cube across, okay, so it moves, it becomes the opposite of what it was doing on the left. It'll end up square rooting that number. Sorry, not square rooting, cube rooting that number. Okay, that's what I've shown here. Put that to the calculator. I end up with 42.2, and it says to round to nearest millimeter. The 0.2 is less than 5, so it stays at 42. And I include my units of 42 millimeters. And that's that. Okay, so that's part C. I think it's the end of this question. Yeah. So thanks very much, and see you in question 4.